Welcome to this video. We're going to be talking about dividing complex numbers. So to start, let's think about an equation, 3 plus I times x equals 4 plus 2i, where we would want to use division to solve it, but that we can't just yet. So let's solve it using a different method. Think about the multiplication of two complex numbers. You get this sort of formula. We can actually use this to solve our equation here for x without having to use division, so to speak. So the way we do it is, remember that if we have right here a plus bi, then that means a is going to be 3 and b is 1. So kind of plug into our right hand side here, we have ac minus bd, so I put 3c minus d because we don't know what c and d are, that's what we're looking for, and bc plus ad, which b was 1 and a was 3. So here's your two equations. Now we can easily solve these. I think the fastest way is just to multiply the top one by 3 so that you'll have a 3 in front of the d term, and then you can add them together and it'll cancel. So if you do that, you get 10c equals 14, and then therefore c has to be 7 over 5. Once you find that, you can plug it back into either of the two equations and solve for d, and so you get d is 1/5. Putting those two things together, you can write your new complex number, which can be 7 over 5 plus 1/5 I. So that's what x is. We kind of used a roundabout way to solve it, but now let's talk about an easier and quicker way to solve division questions. So division is the only operation of complex numbers that we have not yet discussed. Let's look at that same question. We would really like to just divide 3 plus I on both sides of this equation and figure out what this equals, but how do we do it? So the trick we're going to use is actually the difference of squares. So remember, when you have two difference of squares, so like a plus b times a minus b, the middle term actually cancels, and so you only are left with a squared minus b squared. So that's convenient for us because we want to get rid of the I term on the denominator of our expression. So when we multiply by what we're going to call the conjugate of the denominator, the I term will disappear. So like in that same example, we're going to multiply this fraction by 3 minus I over 3 minus I. Remember, anything divided by itself is just 1, so we're not changing the value here. We're just changing the way it looks. So in the bottom, we get 3 squared minus I squared. Well, that's going to be 9 plus 1. And then on the top, we're just going to simplify our multiplication. Going on further, we get to the same answer we had from before, 7 over 5 plus 1 over 5i. So it worked. That's the trick we're going to use, multiplying by the conjugate of the denominator. So let's go ahead and try another example. If z1 equals 2 plus I, z2 equals 2 minus 5i, and z3 equals negative 1 plus 2i, find the following z1 squared divided by z2 times z3. First step, let's just find the numerator and denominator separately. So we take z squared here, which would just be 2i times 2i, 2 plus I times 2 plus I. Simplifying it out, you get 3 plus 4i. Same thing on the bottom, 2 minus 5i times negative 1 plus 2i, which is just the value of z2 and z3. Simplifying it out, we get 8 plus 9i. From there, we're gonna find the division of these two things, and we're gonna use that multiply by the conjugate trick. So the denominator is 8 plus 9i, so we're gonna multiply by 8 minus 9i on the numerator and denominator. Simplifying it out, we're gonna get 60 plus 5i over 145. We can simplify that a little bit more and get 12 over 29 plus 1 over 29i. And so that's our result. The next type of question we will see involves proving statements about complex numbers. And remember that left-hand side, right-hand side proof technique, that's the one we're going to use. So just show through algebraic manipulation that the left-hand side of the equation is equivalent to the right, and you'll have proof of what you're trying to show. So for example, prove that z times z conjugate equals the modulus of z squared. So to prove this, we just got to remember a couple things. Z is a complex number, so Z is the symbol we usually use, and Z with a little c stands for the conjugate. So in this case, it'd be A minus BI. And then z with the absolute value is the modulus, which is equivalent to the square root of a squared plus b squared. So let's go ahead and prove this is true. So we say z is a plus bi, and z conjugate is a minus bi. We can clearly see that a times bi times a minus bi, which is just the left side of this equation, is equal to a squared plus b squared. That's really the definition of a conjugate there. Also, we recognize the right-hand side, which is just the square of the modulus is the square of the square root here, which will cancel and leave us just a squared plus b squared. So quickly we can see left-hand side equals right-hand side, and we're done. Wasn't too complicated. All right, and that's all you need to know to get started on the practice assignment. So go ahead and find it on Schoology and start working on it. You can let me know if you have any questions.